Right, hello. So in this video, we're going to review how to do the transformations of our sine and cosine graphs. So I'm going to start by giving you the graphing form of these graphs. So the one graphing form for sine, we're going to say y equals a times the sine of dx plus d. And cosine is going to be the same thing, we just substitute it with cosine. So a times the cosine of dx plus d. Now I want us to look and see, what does this mean? We did look, you should have already seen the last video where we talked about how to graph y equals sine x when a is 1 and b is 1 and d is 0, and y equals cosine x when a is 1, b is 1, and d is 0. And so we're going to kind of talk about how we can transform these graphs. I'm going to do that by starting off by looking at Desmos. Should have it. All right, so here we are at Desmos. You can see our graph right here for y equals sine bx plus d. And I said let d equal 0, b equal 1, and a equal 1. So again, that is the same thing as just y equals sine x. You can see the red and black are the same graph. Actually, let's keep that there, y equals sine x. And let's see what happens. Can I change the color? All right, I got it blue. So blue and red are the same graph. But we're going to play around with it a little bit. So just a reminder, this is our graph of sine. We said we start here at 0, 0. When we get to pi over 2, at pi over 2, the sine is 1. Sine of pi over 2 is 1 because on the unit circle, at pi over 2, the y value is 1. So that's why when our x is y over 2, our y value for this graph is 1. The sine is 1. When I get over here to pi, the sine of pi is 0, so that's why pi comma 0. When I get to rad 3 over 2, the sine at rad 3 over 2 is negative 1, and sine at 2 pi is 0, and then it just repeats itself. So we call this a period of the graph. How long the graph takes to repeat itself? Well, between 0 and 2 pi, it completed one complete cycle. And if I look here again, so I'm at 2 pi here, how long does it take to complete another cycle to go up and back down to here? Well, between 2 pi and 4 pi is 2 pi. Let me guess, the next one's going to be at 6 pi. So I'm here at 4 pi, and it's going to repeat itself again at 6 pi, and then 8 pi, and so on and so forth. So right now, we would say the period of my graph is 2 pi. Let's take a look at some other words. We're going to learn the word amplitude. Amplitude is going to be the distance between the midline and the minimum and maximum. So we need to learn what a minimum and maximum are on a midline. My maximum, you could probably guess, is going to be the tallest part of my graph, and that's going to be at 1. I'm looking at the y value here. It goes up to 1, and my minimum is going to be negative 1. My highest sine value is 1. My lowest sine value is negative 1. My midline is going to be the line between 1 and negative 1, which in this particular graph, y equals sine x, that amplitude is 1. And maybe you can see a equals 1 here. That's my amplitude. My midline, we said is going to be this line because it's equal distance between the minimum and the maximum. So where's that midway point? It's going to be right here at 0. The midway point between 1 and negative 1 is 0. So my midline is 0. So maybe let's see what happens with D. If I play around with D, if I increase D, what happens to my graph? My graph is shifting up. Let's say I made D2. I can get it at 2, right there. Well, what happened to my entire graph? Here I had 0, 0. Here I have 0, 2. Here I had pi over 2 on the x-axis and 1 on the y. What am I going to have here? Pi over 2, 3. Here I had 3 pi over 2, comma 1. Here I'm going to have 3 pi over 2, comma positive 1. Over here is negative 1. So I just took every single point of my original blue graph, y equals sine x, and I shifted it up 2 because my d value was 2. What else did that do? Well, it moved the midline to 2, that point between the minimum and the maximum. My maximum was 3, my minimum's 1. What's halfway between 3 and 1 is 2. My midline is 2. You can see that relates to the d value of the graph. What do you think happens if I bring it down to negative 4? Where do you think my new midline is going to be? It's going to be down here at negative 4. I shifted the whole graph down 4. My new midline is at negative 4. My new maximum is at negative 3. My new minimum is at negative 5. And what's the midway between negative 3 and negative 5? Negative 4, my d value. So my d value is going to shift the graph up and down. So at my parent graph, y equals sine x, my d value is 0. There's a plus 0 out here. Now let's look at a next. What happens if I shift a up? Oh, it's going to stretch. What's going to happen if I make a between 0 and 1, let's say? It's going to lower my amplitude. Remember, my amplitude is that point between the maximum and the midline. Here, my amplitude was 1. Between 1 and 0 is 1. Same thing between negative 1 and 0 is also a difference of 1. Now, what if my a value was 0.5? Well, now I'm going to have pi over 2, comma 0.5, and 3 pi over 2, comma negative 0.5. Those are my new maximum and minimum. My midline is still 0, but my amplitude is now 1/2, the distance between the maximum and the midline, or the minimum and the midline. So this is going to be very similar to when we were graphing polynomial functions, and an increase in an a value made the graph vertically stretch, whereas a decrease in an a value made the graph vertically compress. And just like in our other polynomial functions, what do you think is going to happen if the a value goes negative? Well, it's going to flip the graph. So if I did a is negative 1, I just took every single point and I flipped it. So now at pi over 2, instead of it being positive 1, our sign is negative 1. And so on and so forth. Every point has been flipped. That is what it does. And if my a value goes further than negative 1, it's still a vertical stretch. As long as the absolute value of a is greater than 1, we'll have a vertical stretch. Whereas the absolute value of a is less than 1, we'll have a vertical compression right here, compressing towards that midline. Right, so again, let's review what D did. D brought it up and down. A vertically compressed it, like that, vertically compressed, or vertically stretched it, or could flip it entirely. Now, what do you think B is going to do? Let's see. If I increase B, what happens? All right, I fixed it. So again, my blue graph is going to remain my parent graph, y equals sine x. And let me see what happens as I move B to the red graph. As B gets bigger, it looks like we're horizontally compressing this time, like taking an accordion and compressing it. Let's see, if B was 10, now how long would it take to complete a whole period? Before, we said it was 2 pi to go all the way up to the maximum, all the way down in the minimum, and then back to the midline was 2 pi. What do you think happens now that B is 10? Let's see. Starting here at 0, 0, I go up to my maximum, down to my minimum, and then back here again. Now I'm at pi over 5. So I horizontally compressed it. You notice pi over 5 is 1/10 of 2 pi. So I took 1/10 of 2 pi and I got my new B value, which is, or my new period is pi over 5. So that 2 pi divided by my b value, 10, got me my new period, pi over 5. Now what do you think happens as b gets smaller? Let's see, let's not go negative. B gets smaller, we are horizontally stretching. So look at that again. As b becomes a fraction less than 1, we are now horizontally stretching our graph. So let's make b 1/2. Let's see what the period is now. So now if I start at the midline, go up to the maximum, down to the minimum, back to the midline, where am I at? I'm at 4 pi. So again, in my parent graph, blue, I'm at 2 pi one period. Now I'm at 4 pi when b was 1/2. You might also see this as 2 pi divided by 1/2 is 4 pi. So our b value is related to our period. It's not exact. My b value is 1/2 and my period is 4 pi, but they are related by this 2 pi period that occurs when b is equal to 1. All right, let's go ahead and look at, or we will write this down actually. Go back to our notes. And let's write down what we learned happened here. A is going to equal the amplitude in our graph. And let's talk about how does that shift the graph? Well, we said if the absolute value of A was greater than 1, then we have a, again, if it's greater than 1, we're going to have a vertical stretch. If the absolute value of A was less than 1, so if A is a fraction or a small decimal, that's when we have a compression, a vertical compression. And we said if A was negative, a negative A flips the graph. All right, and let's see, B is going to have this fun relationship with our period. When B is 1 in our parent graph, the period is 2 pi. And so we will learn that B is going to equal to 2 pi over the period, which also you could cross multiply this and get B times the period equals 2 pi, and then you could divide both sides by B. So another way to look at this is the period is equal to 2 pi over B. So if you know your B value, you can divide 2 pi by B and you'll know your period. If you know your period, you can do 2 pi divided by the period and you'll get B. So what did we learn? Well, we learned again that if the B value or the absolute value of B was greater than 1, we had a horizontal stretch. We learned that if the absolute value of B was less than 1, we have a horizontal compression. And then our last one was easy. D is going to be your midline. Another way to look at it is that the vertical shift. A vertical shift, meaning if your D is greater than 0, the absolute value is greater, if D is greater than 0, you will shift up by that many. And if your D value, actually this isn't even absolute value anymore, because a negative D value will shift it down. So a negative D value, D less than 0, will shift it down by that many. All right, so what does that mean? Let's see if that works for our cosine graph too. Let's go back here. So that was sine. Now let's look at cosine. And the cosine graph has some similarities and some differences. I'm going to go ahead and also graph down here y equals the cosine of x in black. That's the color it chose. So there's my parent graph. You can see this is this graph when a is 1, the amplitude is 1, d is 0, the midline is 0, and b is 1, which means 2 pi over b is 2 pi, which means my period is 2 pi. This time, instead of starting at the midline, going to the maximum, midline, minimum, midline again, now my cosine graph starts at the maximum and goes down to the midline, down to the minimum, back to the midline, and then back to the maximum. But look, how many times did it, or how long did it take for the graph to complete a whole cycle before it starts repeating itself? 2 pi. Once again, my period is 2 pi. My minimum is -1, my maximum is 1, which means my midline, my d is 0, and my amplitude between 0 and -1, or the distance between 0 and 1, is going to be 1. So again, on my notes, look at your notes, we wrote that when a is negative, it flips the graph. Let's try that. Oh yeah, it flipped. The red value is now the negative a. We said when my a is a fraction, less than 1, greater than 0, my amplitude horizontally compresses towards the midline when it's a tiny little number. And we said when a is bigger than 1, my amplitude creates a vertical stretch. And again, that works for absolute value too. If you have a negative tiny little fraction, it's going to compress it towards the midline. If you have a negative number bigger than 1, it's going to vertically stretch it. Put the amplitude back at 1. My b value, we said it as b gets bigger, my graph horizontally compresses. Oh, I'm sorry, I wrote that down wrong. Let's change our notes. I'm sorry. As b gets bigger, we have a horizontal compression. And as b gets smaller, we have a horizontal stretch. Please make sure you fix that. I messed up. Let me go back. As b gets bigger, we have that horizontal compression. As b gets smaller, our b values will be between 0 and will be greater than 0. As we get fraction b values, we have horizontally stretch. And then look at your notes. The d value is going to be a vertical shift. If it's greater than 0, we'll shift up by that many. If my d value is 5, then the whole graph shifted up by 5. Instead of 0, 1, now 0, 6. Shifted up by 5. If my d value is -3, my whole graph shifted down 3. Instead of 0, 1, now 0, -2. All right, let's do some more practice. Let's say it is asking you to graph. Here, let's graph let's do this one. We will graph y equals 2 plus 6 sine 8 or theta. Sometimes you'll see theta, sometimes you'll see x. All right, let's figure all this out. What are all of my transformations going on? Well, you want to be careful. A is the one being multiplied by sine. So in this case, my amplitude is 6. A is going to be 6. My b value is going to be what's being multiplied by x. So b is equal to 8. And my d value is going to be the one out here on the outside. Don't let this confuse you. The order. I could put the +2 out here, it'd be the same. That's not being multiplied by this, being added. So my d value is 2. All right, so what does that mean? Well, if I were to write my transformations, you'll see a lot of times on your worksheets, it'll tell you to write your shifts or your transformations down. So what do I know? Well, I know that my a value is greater than 1, so it's going to vertically stretch. I know that my B value is greater than 1, so it's going to horizontally compress. And I know my D value is 2, which means it's going to shift up 2. So if you get on your worksheet or you have a question that asks you to label the transformations, here are the transformations. If we were to graph this, I would need to know the period. So I know from up here that my period is going to equal to 2 pi over my B value. So my period is going to be 2 pi over B, which is 8. 2 over 8 is the same thing as 1 pi over 4. Oh, so that's going to be a tiny graph. So what does that mean if I were to graph it? Well, it doesn't have to be perfect, but it is going to be a sine graph. So I know it's going to start at the midline and then go up, midline, down, and then back to the midline. So I'll start here at 0, 0. I know it's going to go up 6. So if I were to, let's say I just drew my sine graph. It's a little bit more even. All right. So let's see, what do I know? I know that this is 0, 0. I know that right here is 1 full period. I will have gone pi over 4 to the right, and then I'm back to 0. What else do I know? I know that this point is going to be halfway between here and here. So if this is pi over 4, if this is 1/4, this becomes 1/8 a pi. Pi over 8, comma 0. All right, what's going to be up here? Well, oh, I'm sorry, I messed up. This is going to be my midline, which is going to be 2. So this is going to be 0, comma 2, comma 2, comma 2. What do I know? I know that my amplitude goes up 6 for my midline. So my 2 plus 6, my y value is going to be 8 there. Down here, 2 minus 6, my y value is going to be negative 4. And then I got to figure out the x value between the halfway point between 0 and pi over 8 is going to be pi over 16. And halfway between pi over 8 and pi over 4. Well, let's see, if this is 1 pi over 16, 2 pi over 16, it's going to be 3 pi over 16. Down to negative 4. So what does this show me? It shows me that my A value is 6. My amplitude between 2 and negative 4 is 6. My B value is 8, which means my period is pi over 4. And my D value is 2. There's my midline at 2. You could even kind of draw this dashed if you want to draw like the real 2 down here. All right, let's try another one. Let's say I want to graph. Let's do a cosine one this time. Let's do y equals negative 1 plus, we'll do 3 cosine 4x. All right, so let's write out my values, my A, my B, and my D, and then we'll write how that transforms the graph. Again, it might ask you to write how it transforms, it might not. It might only ask you to write how it transforms or shifts the graph without even asking you to graph. That would be cool. All right, so my A value is going to be 3. So if my A value is greater than 1, I vertically stretch. Vertically stretch. My B value is going to be 4. If my B value is greater than 1, I horizontally compress. Horizontally compress. My D value is going to be negative 1, which means my midline is negative 1 and my graph shifts down by 1. All right, so let's draw this graph. It's going to be a cosine graph. So there's 0. We'll make my midline negative 1. I'll do it better this time. You should do it this way. Always start by drawing your midline. B equals negative 1. Then I'm going to write, let's see, I always start my cosine graph at my maximum. So what's my maximum going to be? Well, if my midline's -1, I'm going to go up 3 to get to my maximum. So 1, 2, 3. So that's going to be at 2. So right here is my maximum. If I go down 3, I'm going to get to my minimum, and then back to the midline, and then back to the maximum. My cosine graph looks something like this. So I labeled my midline, which was -1. I can label my amplitude right here, which is 3. Right, A equals 3. 2, -1, 2 is 3. Also down here, let's label these points. You always want to label these points on your graph. So I know I need to find my period. My period is going to be equal to 2 pi over my b value, which is 4. So 2 over 4 is going to be the same thing as 1/2, or pi over 2. So let's just start labeling points. Over here, my x value is going to be pi over 2, comma, what's my y value? 2. Over here, my point is 0, comma 2. Down here, my x value is going to be halfway between 0 and pi over 2, which is going to be pi over 4. And my y value is going to be my midline, -1, minus the amplitude, which is 3, -1 minus 3. I'm down here at -4. All right, what's this spot going to be? Well, halfway between 0 and pi over 4 is going to be pi over 8. And my y value is -1. Over here, let's say I had 1 pi over 8, 2 pi over 8. I'm going to have 3 pi over 8, comma, -1. Do a few more. I'll do y equals, we'll say 1/2 sine, I'll do a -1/2, how about that? -1/2 sine, let's do another, let's do 1/4 x, or theta, and we'll do +0 this time. So we will label our points A, B, and D, and talk about what shift that's going to make. My A value is -1/2. So what's that going to do? It's going to vertically compress. You can just put vertical compress, and because it's negative, it's going to flip it. My B value is 1/4. So if my B value is less than 1, this is going to be a horizontal stretch. And my D value is 0. So no vertical shift. All right, let's see, how am I going to graph this? I need to remember that my sine starts at the midline. If you can rhyme sine with midline, and remember sine starts at the midline, or your cosine starts at the maximum, or if it was -a, it would start at the minimum. My sine will always start at my midline. My midline here is 0. Love it. So I have 0, 0. Because my A value is negative, I go down first. If it's positive, remember I go up and then down, but I'm actually going to go down and then back through the midline and then up and then back here. Now I got to label my 5 points. Let's see, let's start with my midline. My D was 0 and my A value is 1/2. So that means right here is 1/2. And that means down here is -1/2. So let's see if I were to label these. I don't know the x coordinate yet, but the y is -1/2. The y up here is +1/2. The y value here is going to be 0. Here it's 0, and here it's 0. Let's fill in my x values now. My 1 full period is going to be, let's see, my period is going to equal to 2 pi over 1/4. Well, mathematically, I can multiply both the top and the bottom by 4. What do I get? That's a 1, 2, pi times 4 is going to give me 8 pi. So I know 1 full cycle is going to be 8 pi. That's 1 full period. All right, now I'm just labeling. Halfway between 0 and 8 pi is going to be 4 pi. Halfway between 0 and 4 pi is going to be 2 pi. And halfway between 4 pi and 8 pi is going to be 6 pi. All right, we'll do one more. Graph. We'll do y equals, we do negative cosine, do negative 2 cosine of 1/8 theta plus 4. All right, last one. So A is going to be negative 2, it's my amplitude. So what shift does that tell me? Well, it tells me it's going to do a vertical stretch and flip. It's going to stretch because the absolute value of negative 2 is greater than 1, and it's going to flip because it's negative. My B value here is 1/8, and I learned that when I have a fraction B value, it's a horizontal stretch. And my D value here is going to be positive 4. So it's going to happen, I'm going to shift the whole graph up by 4, and that's my midline. All right, let's draw this graph. Ooh. Okay, I'm going to say my midline is 4, so we'll call this right here D equals 4. You could put Y equals 4 too. It's your midline. It's a negative cosine, which means instead of up here, for my first cosine with a positive A, I started at the top and then I went down. Now I'm going to start at my minimum, and I'm going to go up to the midline, up to the maximum, back down to the midline, and back down to the minimum, and there's one full period. So now I'm just labeling my 5 points. Let's do the Y values first. So these Y values are going to be 4 each. My amplitude is 2. The absolute value is going to be 2, which tells me that the distance between my midline and here is 2. So between 4 and here is 2. So that's going to be 6. So my Y value here is going to be 6. My Y value here is going to be 4 minus 2 is going to be 2. And same thing over here. It's going to be something, 2. All right, now we got all of our Y values. Again, this is my midline. My amplitude was 2, so up 2 to the maximum, down 2 to the minimum. And midline is 4. Now I need to find my period. So my period is going to equal 2 pi over B, which is 1/8. So I multiply the top and bottom by 8. What do I get? I get 16 pi on the top and 1 on the bottom. So my period is going to be 16 pi. So that tells me if I start at 0 and it finishes at 16 pi. And I'm just going halvesies, okay? Halfway is going to be 8 pi. Halfway between 0 and 8 pi is going to be 4 pi. Halfway between 8 pi and 16 pi is going to be 12 pi. And there's my graph. And that will be it for today.